we're going to be running our first paired t-test. So we've got 10 men here, Alan through George, that are testing an exercise. So I said Jorge one year, and one of the kids said it's George. So I can go back to Jorge if you want. Okay, all right, Jorge it is. Sounds good. All right, don't forget Grame, my personal favorite. So they are testing this exercise device. Last year I said the Peloton, but we can say whatever you want. There's an exercise device you care about a lot. They have their resting pulse rates before doing this regimen of 6 weeks, 3 times a week for 20 minutes each day, and then their resting pulse rates after. So my first thought when I'm reading this problem is I have 2 groups of data values. Is there a link between them? Yes. What is the link between these before and after resting pulse rates? It's the same person. Well done, Victor. So the moment you see that it's the same person, we know that I'm actually going to treat this as paired data. So what I do is I make another column. Oh, that's not very good.
Is it the difference?
And it is the difference.
So instead of typing 2, 1 and 2, we go straight to.
Now you can if you want, right? I'm going to type them all in and show you how you can use the calculator to do it for you. I don't know if it's faster because these are pretty simple to subtract. What's 73 minus 73? 0. 83 minus 79? 4. 85 minus 81? Keep going. Then 8. Then 3 for Graham. Then 2. And then what about Ivan? Ooh, it went up. So what do I put? I've been putting positives on those though, Thomas. So it should be negative 1. Sick. And then 3.
We're the best.
So if you haven't started typing in, you can type in just those if you want. I will show you how to do everything in the calculator.
Wait, do we technically only need the difference?
Correct. Once you find their pair, Thomas, I don't care at all about anything but the difference. All right, but let's say you had them typed in. I'll type them all in now. And I can show you how to get the calculator to do the difference for you. All done, Thomas?
No, not even close.
Okay.
I gave up.
Persistence, good job.
Thank you, sir.
Yeah, I think everybody watching this video stopped watching.
They can skip it.
They just skip it. Okay. Okay, so once I have them in, if you want the calculator to do the subtraction for you, like I would never, if I spent the minute or whatever it took, 2 minutes to do that, I would never then do the subtraction mentally. I would just have it do it for me. So if you go over to list 3, all right, and then actually hit up to go into highlight list 3, so I went up to there, you can type in second, let me get it here. You can type in second 1, which is list 1, minus second 2, which is list 2, and it will do it for you. Okay? Now these are so simple, you can just do it in your brain, but if the numbers are more complicated and you don't want to subtract it, you just do it that way. Okay? So again, from now until I'm done with the problem, do I care about list 1 and list 2? No, it's as if they're not even there. All I care about is list 3. Okay? So now let's think about, we're about to run a test. What is the first thing we should do when we run a test? The parameter. All right? So just one parameter. Okay? Does anyone have any idea what I'm going to say? Let. Yep. Mu, I like it, right? We're still talking about means, but I'm going to use a subscript, all right? I'm going to use a subscript of D for difference. Represent the average difference in resting heart rates before and after this exercise program. All right, so if you're doing a paired t-test, just one parameter. Now, the hypothesis, the null hypothesis, is always going to be the same. Unless they tell you otherwise, what are we assuming is going to be my difference between the before and after resting pulse rates? 0, that they're the same, right? We always assume no difference. Okay, now this one can be a little trickier. Right, we know we're going to copy down mu sub d, copy down 0. I've got 3 choices. I've got not equal to, I've got less than, I've got greater than. Let's go in the problem. All right, let's highlight the problem. It says, is there evidence that this kind of exercise can reduce resting pulse rates? And just be careful, because if you're trying to prove that it's reducing them, what should happen to the after numbers? They should be lower. But we're subtracting before minus after. So if the after numbers are smaller, I am hoping that these numbers are actually what? These differences are positive, right? That's the hope. So even though it says reduce, I'm actually going to be using greater than, right? And that is the trick, and that could mess you up on the AP exam. I'm going to pause here. Any questions on that? Because that may not be, something that just makes sense right away. Because I've been telling you guys for like weeks that if you see reduce or get smaller, or if you see it increase or get larger, to have that be your sign. Be careful here, because we're talking about the difference in 2 things. Okay. How's everybody feeling about the parameter and the hypotheses? Doing okay? Super. Oh, amazing. Nice. All right, let's go to the next page. All right, what comes next? Assumptions. The first one I'm going to do, because you notice so far with my parameter and my hypotheses, I am saying what about the data here? They are linked. I usually do independence first, and it's not wrong. I don't care the order you do, Leslie. But because I know I'm going to do a paired t-test, I get that out of the way. I want to tell whoever's reading this that these 2 groups have a link. And what is the link? Victor said it earlier. What's their link? It's the same person. Okay? So these data values are from the same people. Okay, now we can do independence. Who wants to give us the independence statement? Okay, Thomas?
One person's heart rate won't impact another.
Excellent. I told this story in this video. Did anyone watch the video of me doing this?
Tell the story.
Okay, I'll tell the story. I just don't, there will be people out there that watched it that, well, maybe not, that be like, oh, you already told the story. So when my wife was in the hospital with Henry, so our first experience of her having a child, they hook her up to some monitors, and her resting pulse rate is so low, right? It's so good that the monitor would beep because it thought she was dying. Yeah, the nurse comes like charging in, like, oh my gosh! I was like, she's fine. She's totally fine. Like, they had to actually turn the monitor off because it kept beeping so much, right? That's her resting heart rate is amazing. It's incredible. Yeah, I'm serious. It's below that. It's like low 50s. Yeah, it's something absurd. Yeah, like doctors are always like, "Are you okay? Are you alive?" I'm like, she's okay. I don't know what the number was, but man, it was hilarious. Yeah. Yes, it happened with Catherine, but our third one, Liam, we had at a different place where it was a birthing center, so it was less about monitors. It was about more like the holistic approach. We did all different manner of things. You have enough kids, you can do Lots of different birthing areas. Super fun. Okay. Yeah, that one had a bed, right? Most of the hospitals just have like a couch. So I should have slept. It was awesome. Yeah, I get a lot of grief from the wife for like sleeping through Liam's birth. Like, listen, you had so many kids. Like, what do you want me to do here? Like, I'm tired. Right? I know you're working hard, but I'm still tired. All right, I'm just chilling. Okay. So bad. Listen, you know what? I don't apologize. Okay. Thank you. What do we do next?
Randomization.
Yes. Does it say random? No, it says volunteer. I'm a little worried. Not that I have an issue with volunteers, but when I see volunteering to do an exercise program, what am I thinking about the people that are going to do that?
They're athletic.
Yeah,
they're trying to
They
be
probably are interested in this and might be more athletic than the random person on the street. So that would be my concern. So the statement I write is, these 10 men are a good representation. Does it say our population? What do we think the population is going to be here? What do you want to limit it to? Like the city of Houston, like the state of Texas, the world?
American.
Only Americans? Okay.
I mean,
Of American men? I have no idea. All right, so let's multiply it by 10. Are there more than 100 American men?
at
I
least
think so, right? If you're not singing the song Africa by Toto, sad for you. Nothing that 100 would ever do.
You should sing it.
My math teacher from middle school loved that.
Oh. Who is this guy? I need to meet him.
Yeah, he's incredible.
Yeah, what's his name?
Mr. Eller.
Mr. Aller? Eller. First name? Do you know? Jeff. Love a good Jeff. Geoff or Jeff? Got it.
I'm invited to my graduation.
Are you? Nice. Oh, awesome. Okay. What's next? Don't say the sample size assumption.
I was gonna ask if
Yeah.
like if the first one was like the data value from the sick people, if that's like our new assumption.
Yes, so this is the paired data assumption.
Okay.
So yes, this is the new one. The only really new one, Thomas.
One more thing.
Yeah.
If we do,
Doesn't need to be one more thing.
Okay. Is it-
Another thing.
Yeah. If we feel like we did well on the AP test, can you sing for us?
Sing for you?
Yes, like a full song. A full song.
A full song? I gotta.
That would be
No,
No, I'm not doing that song.
Because,
Yeah, it really depends on the song, right? I told you about the one time that I went to a karaoke place. I didn't tell you about this?
you should tell us. Story.
Joseph! Oh my gosh, welcome. I am recording, always. Right? No, I'm not. Whoa, say something. Say something.
People in the video are so confused.
They're so confused. They're like, what did he just do?
Oh, no, I did.
Joseph wants it.
Seeing our records.
So one time I went to a karaoke place in Chicago with like 8 people. It was like where they had like your own room. And so you got like, my traditional experience with karaoke is at like a larger establishment. And so you might get one song in the span of a couple hours. But when you're in the room with like 8 people, you get lots of songs. So you kind of run out of your like go-to songs. So like you start with, I don't want to say my songs, but you start with like your O-Town All or Nothing, right? Anyone know that one? No one knows that one? 'Cause I want it all or nothing at all. That one? You remember that one? I mean, you may not even been born yet, but I know that one. That's a good one. Anyway, so I ran out. Chapter 25, you should have it. You don't?
No, I turned in the clues when I put the bell wrong.
Oh, so it was my fault. Got it. Okay.
No, I'm saying it's my fault.
You're good. So I ran out of like go-to songs. And so I was like, all right, what do I do? And I saw they had Josh Groban in there. Yeah, and so I did You Raise Me Up. And that one didn't really go over very well because the vibe was more like fun, and that brought the vibe to a different place. Yeah, so I think we just all left after that. Anyway.
Okay.
All right. The next thing we need to do is we need to assume what about the population?
It's normal.
That the histogram for the resting pulse rates, that difference would be normal, unimodal, and symmetric. So the histogram.
Wait, do we actually make the histogram?
So we're going to make the histogram for these 10 men, but we don't know the histogram for all the men. We hope that if I found the difference in these men with their resting pulse rates before and after they did the exercise program, that it would be normal. Again, it's a lot tougher when it's a study because you just don't have that information. All right. So now we can go into the calculator and make it. So Joseph, you're going to need to catch up, I think, on the calculator stuff. Just type in my list 3 when you get up here, when I show it. So just see my list 3. Just type in those. You can type them into list 3, Joseph, or into list 1, your choice. If you out there listening are ready to make the histogram, go ahead and do it. You know how to do it, right? Second y equals. Let's see what this histogram looks like. You can't see them? Hopefully it's unimodal and roughly symmetric. Is the batteries low?
No, it's just not working.
It's not working? Tracer.
It's just done.
Wait, hold on. You still need, after the number 3, you need 2, -1, and 3. 2, -1. Got it? All right, here we go. Second, y equals. Turn the first one on.
Sorry, I never need.
It's okay. Make sure you click the histogram. Graph. Zoom 9. All right, what do you guys think? No? Did you do Zoom 9? Yeah, for list. Oh, I know what I did. It's me. I did it. I'm wrong. You're good. I didn't do list 3. Might be. See? Jonathan, I need more dum-dums. There we go. Why does it look like that? Because there is a negative, right? The -1. So this bin is probably -1. And how many zeros did we have? There was 1. So there's 2 of them. So 3. Do we have 2 zeros? Or do we have a 1? Let's see. Is there a 1? So it probably put these together. 0, 1, and -1 in that first bin. All right. So that's why you're seeing this bar is 1, 2, 3. Okay. Is that unimodal and roughly symmetric? No, you can probably convince me it's unimodal, like one main hump here. But it looks like there's potentially because of, who's that?
Franco, he's a very stressed man.
Franco. Interesting. Yeah, he had the highest before, and he still has the highest after, but he had the most opportunity for improvement, if you will. So that's good and bad, I guess. So anyway, I'm going to note that it is unimodal. So the histogram, and I'll sketch it here in a moment. I'm actually going to write a potential outlier. Because isn't Franco double the other highest ones? Right, 8 compared to 4, I want to say. Yeah. All right, so let me draw it here. There were 3 of them, and then a gap. Okay, let's write our sentence. The conditions have been satisfied. So I will use the T model with any ideas on the degrees of freedom out there?
9.
Nice. How'd you do that, Thomas?
Because there's only one sample, so it's just
Nice.
10 minus 9.
Well done. So that's why I said, like, yes, what we're doing is new, but it should feel similar, right? Should feel the same, right? Because now we're kind of doing the stuff that we did a few weeks ago. All right. So the sample size is 10 men minus 1 is 9, with 9 degrees of freedom. To run a paired t-test. Right? And what we will do next week, after we practice a little bit more of the paired t-test and paired t-interval, we'll practice that on Monday. What we'll do, I believe I have it on Wednesday of next week, is we will do a Kahoot. I know, it's back, baby. We'll do a Kahoot where I give you a problem, and you've got to tell me based on reading the problem, should we do a 1-sample t-test, a 2-sample t-test, or a paired t-test?
Can we do a lot of those?
Yes, especially when we do the review for the AP exam. I've got a whole Kahoot where it's all of the things are fair game, all the tests we've ever done. And that's the tough part.
Like from the beginning of the year?
Well, not the beginning of the year, beginning of the semester, right? Because we haven't done hypothesis testing. Okay. Now from here, I'm going to transition to the math, right? The mechanics, to show you my work on how I get my test statistic. And essentially, hopefully at this point, you know the p-value, so I can make a conclusion. And if you're out there and you know what you're doing, go ahead. You don't need to wait for me. You know how to do this. Just as a word of caution, just be careful. Like my list 3 is what I care about. And you already saw that I made a mistake with the histogram. So just be careful. Make sure you know like what list do we care about. Make sure you know which one you're using.
What's the name of the test in the calculator?
Interesting. It's not going to say paired t-test. All we're doing is the same thing we did 2 weeks ago with chapter 23. Do you remember what that was called? It's just the 1-sample t-test, which I believe in the calculator just says t-test.
So 2.
Is that what it is? 2, yeah.
Okay.
So that's the confusing part is like, yeah, there's a difference in what we're doing, but it's actually pretty much the same as chapter 23.
I have a question.
Yeah, just.
You said the last time we were doing the 2-sample one, you said do the degrees of freedom minus 1 because there was 2 samples.
Correct. So when you walked in a little bit late. So the problem has 2 groups of data values, right? But we're not doing a 2-sample t-test because there is a relationship between these data values. And that relationship is that these resting pulse rates are from the same person. So when we have a link that connects them, they're not independent of each other. So we have to do a different test called a paired t-test, which is why Thomas was able to get the degrees of freedom, because it's just these numbers I care about now.
You can only get the degrees of freedom from
If the ones.
that from problems that only have 1 sample that are linked.
Well, so either
1 sample
or there are 2 that are linked. Otherwise, you got to do the test in here and copy down the degrees of freedom. All right. I'm sorry, Caroline. I went away from what you were writing down. Sorry about that. Now, if you're doing the test out there, don't put Y bar, put D bar. It's okay. Make sure you put D bar in as new. The difference. Okay. Yes. Mine is list 3. Yes, that's the one I care about. So the sample size was 10. Degrees of freedom 9. I don't know D bar, and I don't know the standard deviation for the difference. I'm going to find that out here in a moment. All right. The formula I'm using is T with 9 degrees of freedom equals D bar minus 0. Remember, if it's not 0, they'll tell you it will most likely be 0 over the standard error of d bar, which is going to be the standard deviation over the square root of n. So that's the same as a few weeks ago. All right, so here we go. Let's turn it on. Stats, tests. You guys said it was t-test number 2. I have data. My null hypothesis value for that mu, we're going with 0. Remember, I need to change my list. It might be in your list 1, so you're okay, but mine's in list 3. So second, number 3. And then, do you guys remember the symbol we used in the alternative? Greater than, which you may want to take a listen to this video for like why it's greater than. All right, so my average is 2.8 for the difference. My standard deviation is 2.530. All right, so if I plug that in, I get 2.8 minus 0 over 2.53 over the square root of 10. What is that value? That's my test statistic. What do you notice about our t value? Is 3.5. I know this isn't a normal value or a normal model, but 3.5 seems pretty far to the right, even for a t model. So I have a slide here that's below it where you can do the sketch. That's where I'm going to draw my t model if you haven't already. Where am I shading?
To the right.
Just one tail, right? Because it's just greater than, so just to the right. All right. I had a couple of students on yesterday's quiz that put next to their alternative hypothesis when they put not equal to, they put to the side 2 tail tests or something like that. And I was like, that's awesome to have that thought, right? And like, I appreciate you writing it down. It made me very happy. If you didn't, it's okay. Just not as happy. All right, so here is 3.5. All right, shading which direction?
To the right.
To the right. All right, and then let's find our p-value, which should be pretty small, 0.003. Again, I did not mention an alpha level or your level of significance, but I usually use 0.05. And I think whether you use 0.05, 0.1, or 0.01, what do you notice about this p-value? It's very small, right? So essentially, what does that allow me to do? Very good. In favor of the alternative. So essentially, do we have enough evidence? And you can always go back. There are some students in here that are really good about doing this, using the problem to help you write your answer. The question says, is there evidence that this kind of exercise can reduce resting pulse rates? And we're going to say what? There is. And you can literally just copy that. There is enough evidence to say that this kind of exercise can reduce resting pulse rates. Yes.
You say there's enough evidence or mention that the p-value is more than the alpha?
I do both.
You do what?
I do 2 sentences. My first sentence is just to say generically, my p-value is below alpha, so here's what I'm going to do. And then I bring in the context. All right. You can do it in 1 sentence, Eduardo. It's not a problem. I just have always, since high school, I've always done it that way and kind of set in my ways now. All right. So my p-value is below alpha. So I will reject the null hypothesis. There is enough evidence to say this kind of exercise will reduce resting pulse rates.